Hi all and welcome back. I hope you can all hear me correctly. What we're going to do now is start moving on from what Eamon was looking at, and we're going to start looking at covering some of the Java basics primarily, and then what we'll do in this same lecture as well, we will move on and start talking about arrays. So you would have probably come across a lot of these constructs when you were doing your lab earlier on, but maybe some of them weren't clear while you were doing the lab. So this lecture will follow up on a lot of the constructs that you would have seen. So what we have is two of the main different types of variables that we're going to be using, two classifications of variables would probably be a better word to use, are primitive and reference. So what we're looking at here, this guy here, this is what we call a primitive. And in Java, there's 8 different primitives. This one here is called double. And what that is it's a decimal point. And we'll have a look briefly at those 8 different primitives. But you have another different type in typical object-oriented languages. You have another type called a reference type. And this is what is here. This is a class that was defined called home policy. And what we're doing is we are building an object of this home policy. So home policy will reference where all of the information stored in that home policy object are in memory. So if we have a look at that, just a quick note there, recall that Java is a statically typed language, and that's why we have to put in types. This one's a primitive type, and that one is a reference type. So this is what we mean by reference type in pictures. So if we just look down here at the double premium, you can see that whatever value is assigned to premium, it's stored directly in the memory location that's associated with that variable. But if you look up here at the string greeting, what happens here is that there is a pointer, a memory location allocated to where the contents of that object is stored, in this case, hello world. So greeting doesn't contain hello world. What it does is it contains the memory location as to where the string is held. And that's what we mean by reference type. Greeting references where our string is stored in memory, and it's the same. This is only one string, is just one type of reference type. There are many more. We will write our own bespoke ones in this module, as well as using ones that come with Java. So we're interested in primitives. I mentioned primitives earlier to you, and you can see here that there's a thing called a byte, short, int, all of these lowercase guys at the end here. These are all different types of numbers. The first 4, byte, short, int, and long, are all whole numbers of varying sizes, byte being 1 byte size, and so on. They all increase in size. And then you've got your float and your double, which are your decimal points. A double is twice the size as a float. We also have 2 non-numeric types called a boolean and a char. Boolean is the same as any other language, which is true or false, and char is a Unicode value, which we'll have a quick look at Unicode as well today, and that is just stores 1 character. What we're interested in here is this is an inheritance hierarchy that we have on this slide here. And what this means is that everything, all of these guys, follow up. Say, pick short here. Short inherits from the number class, which in turn inherits from the object. Everything has object at its root, and we'll talk about inheritance next week. So it's just to draw attention to it there. So what we're interested in here is these guys are called wrapper types. And what these guys do is they convert our floats, our primitive types, into a reference type should we need it. We will explain to you why we need this at later stages when we move into the collections framework. But this is just an introduction to show that you can convert a primitive type into a reference type should you need it. And we will need it as we move through the module. And we'll draw attention to it when we do start using that. And these guys are called wrappers, and they're located in what we call a package. So a package is basically a collection of related classes that come with Java. We've multiple packages. We will bring you up to the API. We showed you the API briefly on the previous set of slides. That's what's generated from your Java doc, and it's our API is our application programming interface. And that's where we will go to find out what types of methods we can use with what types of reference types and so on. It's our reference for programming in this area. So the primitive types that we have here, these are the primitive types that we showed you on the previous slide here. So you've got your boolean, your byte, and so on. And you can see the sizes allocated to each of these. And you can see the minimum values and maximum values. So you can see the ranges 2 to the power of 32 divided by 2, taking into consideration the 0 value, will give you those values. So you don't need to know those values off by heart, just know what 2 to the power of 32 is using your calculator. So Boolean has a value of true or false, and so on. So there's only 8 primitive types in Java, and that's the way it's been since the inception of the language. Your primitive types, we talked about the language, the classification of language, that when you choose a specific type for a variable, it will dictate the type of operators that you can use on that variable. So if we choose, so based on primitive operators, we know that if we choose int, byte, short, long, float, double, these are all our numeric types, we are permitted to do mathematical operations on them, remainders and so on, the modulo. And there's also, like, you know, increment first and so on. We look at all of these guys as we move through the course as well. And here's another classification of them. You're lesser than, you're greater than, and so on. All of these guys here. We can do these on our primitive numeric types. And also we can move on to our relational operators, our and our lazy and so on. So your operators are determined by the type of variable that you define, and these are our primitive operators. So do you remember we were saying it's a strongly typed language? So the type that we allocate at the beginning to a particular variable will dictate the operators that are available to it. So if we look at Boolean for an example, so Boolean we use it in control statements. It's got values of true and false. So when we start looking at our logical operators, there's only a few of these that we'll probably use on a day-to-day basis when we code. Not true. So the not, this is our invert. So invert the value and it will give us a false. So if you're not true, it's false. Not false, it's true. And then we're interested in the and the or. So both and, these are all back to your standard and gates and or gates that you would have done for any language that you would have coded before. So if you've got one true value and this on this side, both evaluate to true. So in order for a logical operator of and for the entire expression to be true, both have to evaluate to true. If either are false, the entire statement is false. So you can have a look at these guys and try these guys out in a CodePad, or try them out in Eclipse and just play around with these. So your char type. So Java is language independent, and what I mean by that is that there's underneath each char, what you have is a Unicode value relating to it. And you have Unicode, many Unicode values. Because it's a 16-bit value, you can have many Unicode values. And there are representations similar to what I've just highlighted here. There are representations for every character that can be possibly typed on a keyboard. I've included just a couple of them in here so you can see Unicode values. So the Latin capital for D is the Unicode value of 44. And there's many ones for the backwards or in Russian, for all different languages. So Java can handle multiple languages, and that's very handy from a localization perspective. There's escape sequence characters. A lot of C would have had these as well. And what it is when you include /n or /t within double quotes in a string, what it does is it says, the minute that Java sees the slash, it says, well, the next character that's coming after the slash is not part of the string, it's a command. So if I have a slash, Java recognizes that the N is a new line. The /t is a tab. So in fact, this, when you embed that into a string in Java, say you're printing something out to the console, Java recognizes these as being commands as opposed to being part of the string. And you'll find that you'll start using these for formatting output in console-based applications. So there's an example. Both of these are the exact same. So you've got system.out.println, hello. So println's print a line, system.out.println world. So there's 2 lines, or we can condense it into one full statement down here. And what we have in this is hello /n world. When the /n is embedded in the string, Java recognizes the second character, which is the N, as the command for new line. It's very handy for coding output to the console. So we've got numeric types. And there's just how our primitives fall into a numeric type hierarchy there. So we've got 4 integers, 2 floating points, and a Boolean. So when we start manipulating these guys, if we add 12 plus 24.56, it's a double. The result is a double. The lesser type is promoted to a greater type, and the operation is then performed. But in this situation here, a greater type cannot be promoted to a lesser type. And this is where Java starts giving out. So this is where it starts complaining about a loss of precision. So if I have a variable called I and it holds the value of 12 and it is declared as an integer, and I declare another value called D with a value of 23.4, if I try and assign D into I, there will be a loss of precision, and Java is very fussy about that and is not happy, and it won't let you do that. It won't compile. It will give you a type mismatch exception in your compile stage, and it will not do it for you. So this is where casting will come in. So we've got 2 types of casting. So in the previous statement that we were looking at, Java just refused to do it. It would not, what we call, implicitly cast the double as an int because it would have lost the decimal point. So Java will not implicitly cast that. And what it's concerned about is there's no information loss in implicit casting. So it won't implicitly cast if it's going to lose data. And you can see on this diagram here which directions it will implicitly cast. So a byte, if I can put a byte into a short, because a byte is smaller, has a less capacity than a short. In turn, an int can hold a short because it has less capacity. An int can go into a float because it's going to fit. It's just the decimal point is going to be 0.0. So you can see what we mean by implicitly casting is whether Java will automatically do it without the loss of data. But our situation beforehand, on the previous slide, it was a compile time error. It was complaining about a type mismatch. In this case, there is another type mismatch. Int I is assigned 34.5. Won't work. Java will not accept that. So what you have to do is you have to, in this case, explicitly cast and say, look, I know it's going to lose the decimal point. I'm happy with it. It's perfect for whatever application I'm building. Don't worry about it. Just put it into the I. I am aware. So explicitly casting is forcing a number that doesn't fit, in this case, doesn't fit into the variable, and letting the compiler know, I know I'm going to lose data. It's fine. Just do it for me, please. So that's explicitly casting. So what we're looking at here is classes and interfaces. So AKA object types. So we've got 2 different reference types that we're going to look at in this lecture. So we will cover interfaces hugely in, I think it's next week we have that planned. So the reference types that we're interested in at the moment are classes. So if a variable is declared as a type of a class, an instance of a class can be assigned to that. And you saw that on Eamon's slides previously when he had a home policy and he assigned a variable, an object of home policy to it. We're going to go into detail into that. And you can also have an instance of any subclass of that class can be assigned to it. So subclass, this is what we're going to start talking about, inheritance. That is something that we will cover in 2 weeks' time. We're just flagging it with you again, that there is subclasses. We're interested at the moment in looking at just the classes themselves. So your interfaces. If a variable is declared as a type of interface, any instance of any class that implements that interface can be assigned to it. So what we're looking at is abstraction here. So the main things that we're trying to get across here in this lecture, we will delve deeper into interfaces. We will delve deeper into inheritance in the coming weeks. But we're just flagging that there are 2 different reference types. One of them is an abstract, is helping us build abstraction into our models, and another one is for inheritance. And we'll look at those guys as well. So uniquely identifying a reference type. We saw, when I showed you the slide on wrapper classes, I drew attention that it was stored in the java.lang package. So what we're looking at here is the wrapper classes would have been stored in a particular location. So it's the package where the class would have been stored. Generally, this translates into a directory structure in real life. So you'd have a Java directory. Within that directory, you would have a lang directory, and then all of your classes, which are Java files, would be all listed within it. So what we're doing is identifying exactly where our objects or our wrapper classes or anything that we're trying to use in our program, exactly where it is stored in that directory class. So the object operators. So we have multiple different object operators that we can use. And we will look at the reference types. We looked at a greeting, string greeting. The greeting variable is an object, it's a reference type, and its class is string. So we know that the object is an instance of string. We'll look at instantiation later and what we mean by that too. Not equal to, identical, and an assignment. We will cover these as well as we move through it. These are your object operators. So if we want to create objects in Java, what you use is a specific method. It's a special method called a constructor. And that's our constructor there. It is the exact same name as the class, and its job is to initialize the object to a starting state. So in this case, we've got an object called first policy, and it is a reference to where this guy has been built. So our first policy object is of type home policy. We have another here called second policy is of type home policy. And in this case, we have a constructor, but we're passing in data. So we have two constructors to build home policies, depending on what type of information we have at the time of building it. So if we look at the code behind that, there will be public class home policy. This will be stored in a home policy.java file. We have one constructor here. Constructors are always public. There is what we call no return type. So in here, there is no return type. We're going to look at that with you as well. And it will always be the exact same name as the class, which is up here. And the job of these constructors, there's one constructor, public, exact same name as the class, no return type. Another one, public, constructor with the exact same name as the class, and no return type. The difference between these guys is the parameter list. You can see here, there's no parameters. And you can see in this one, there is one parameter, double premium. So depending on whether I know the premium or not, I would choose to build my object using this. If I didn't know the premium, set the premium to a default value. If I did know the premium, I would use this one. I would invoke this constructor to build my object. And that's what we've done down here. The first policy, our premium is set to a default value of 100. And on our second policy, the premium is set to a value of 120. So what we're doing is we take in the premium through our constructor. This field is directly this guy here. And what we have is a this.premium. What we're saying is there's another premium field, and it's the one belonging to the class up here, this class up here. So it's this guy here. If I omitted this dot and just did premium is assigned premium, Java is incredibly lazy. And what Java will do is it will look for the variable declaration of this guy, and he will find it here. And if I didn't have this in front of this variable here, Java will say, oh, there's the variable. It will find it, and it will do a circular update on itself, and you will never update the field at the top. So these guys are what are called, at the top here, these guys are what are called your instance variables. So whenever I define a home policy class, each of them will get a premium variable. And it will be filled with either 1,000, or it'll be filled with whatever we set the premium to be. So the constructor's job is to build the object in memory and give the object a starting state. On our one here, we're just setting up premiums. And that's what it's going to look like. the first two guys here, you can see that we have, this is an object reference, this is our object, it is pointing to an area in memory that has a home policy of 1,100. It has a policy premium value of that. The second policy is an object reference to where our home policy object has been built in memory, and it has a value, premium value of 1,200. We have to be very careful with assignment statements when we're dealing with objects. Here's an example why. You can see in this up here, we have each of them is pointing to a distinct home policy object in memory. If I assign first policy is assigned second policy, what happens is I am not assigning the contents of these. What I am doing is I am assigning the reference, which is the arrow, the memory location. So first policy is now pointing to whatever second policy is pointing at. Okay, so we have to be very careful with assignment statements. We'll show you how to jump into the object, retrieve data and set it up and so on, as opposed to using assignment statements and losing. Once you lose your reference, it's gone. Your object is lost in memory and the garbage collector will come along and pick it up from you. So identical objects. So these guys here, when we're dealing with primitives, primitives don't have a reference. Primitives, the value is stored directly in the memory, it's directly in the box, basically. So x is 3 and y is 3. If we assign x and y to be in both the same value, I can then say that x is equal. This is my equality operator. I can say that x is equal to y, and that is a true Boolean expression. But when we're dealing with equality with objects, what is happening here? All that we are doing is checking that they occupy the exact same memory space. So we're not checking the contents of the object, we're not checking the value of the premiums, we are actually just checking that they point to the same object. So we're checking references. And this is something that we need to be careful of, and we will show you how to get around that sort of stuff as well in as we progress through the module. So the reference type variables are identical if they refer to the exact same instance of the class, that is, their memory address is the same. So in this case, what we've done in this code is we have built one object called home policy, an object of home policy with a premium of 1,200. What we have done is build a second reference, an object type home policy, and its object name is second policy, and we have assigned it to whatever the first policy is pointing to. So there's only one object. We have a reference here pointing to whatever this guy was pointing to in the first place. So both of those are identical. We don't have two separate objects built. We've only one object, and they're both pointing to the exact same object. The reason why we don't have two objects is we have only called the one constructor method. So only one object has been built in memory. So equal objects. The previous slide, we looked at the double equal to sign for equality. And that double equals is absolutely legal, perfectly legal to use when you're dealing with primitives, because the data you're comparing is stored in the memory location directly associated with the variable. It is not legal to do it with it's unpredictable as opposed to legal. It's unpredictable to do it when you're dealing with objects. So the first policy, we are creating another object here. We know we're creating the object because we're calling the constructor, and we have two identical values going in both of these guys. So we know that we have two objects. We've called the constructor twice. There's one call. And there is another call. We have called the constructor twice. They both contain the same default initialized data. So when we do first policy dot equal, so what we're saying is first policy, invoke an equality check on it. And we are saying, does the first policy equal the contents of the second policy? We are comparing contents here in this. We are going beyond checking identity, which is the memory location, and we are jumping down into the object and we are comparing the contents of those two guys. So when we compare objects, reference types, we have two things that we need to be careful of. Are you comparing identity, or are you comparing the contents of the actual the contents of the object, as in the data that's stored in it? So we will look at this equals method in detail as we move through the module as well. We'll write our own ones and so on. Null. So null is known as the $1 billion mistake, and we will look at this. What it means is that I'm not pointing to anything. I have no reference. I'm not pointing to any objects. So it's a value that you can put into any reference type. So in this case, what we have done here is string. That's a class. 1. There's my object. 1 is pointing to wherever the data is going to be stored. The data that I'm storing is the literal ONE1. What I have done then is I have said, on that object that is pointing to my data, my literal, I want to assign that null. So what I've done is I've overwritten the memory location of where my literal has been stored, and I have lost the reference to it. I have unassigned my object to its data. And in this case then, I'm just reassigning it with another value. So this object will be lying around in memory with nobody pointing to it, and the garbage collector will come along at periodic stages, and it will clean up objects that we have programmatically lost references to. So in this case here, we can use null in another case as well. So what we have done here is we have said home policy policy. So on that line that I've just highlighted, what we've actually done is we have stated our intent that we will be calling a constructor more than likely at some stage to build an object, but we haven't physically built it. So we are waiting with a null pointer. The object has not been built. We will probably build it later on in our code, but at this stage of the execution of the program, policy holds the value of null. It is pointing to nothing. When I call my constructor, use the keyword new to call the constructor. When you call the constructor, you're physically building the object, and that policy variable here is going to point to that physically built object. So now policy has a memory reference to where your object is stored in memory. And I can do checks like if policy is not equal to null, then print it out. System.out.println, print out your policy. If I didn't do this check, this is why it's a $1 billion mistake. If I didn't do this check, and we'll be covering that as well later on, so this is kind of an overview of where we're taking the module. So if I didn't put this check in here and I tried policy.toString and I hadn't called that, if I had literally just had this and that was null and I tried policy.toString, my program will crash. What it'll do is it will go to the policy variable, policy will hold null, it will try and invoke the toString method over it. Because you're dealing with a null pointer, Java doesn't know what to do and it crashes your program with a null pointer exception. So what we have to do is programmatically control that we're not going to hit a null pointer exception. It will literally just crash your program and that's the end of the program. So because in this case, we have definitely built it. So this is just a to be sure check. So arrays, so that was just the kind of the Java basics. A lot of those items that we looked at there, it's a whistle stop fast tour. A lot of those items we will be coming back to in more detail as we progress through the next couple of weeks. Okay, so the arrays, what we're looking at is an array here and a collection. It's what we're dealing with an array. We've so far looked at primitive types, a variable in isolation on its own. We have looked at reference types. They are another variable in isolation on its own. Most times when you start doing anything meaningful with collections of data, you want to build some sort of a data structure that you can iterate over and manage. And that's what we are dealing with here with arrays. They're what's called fixed size collections containing the same type of element, either a primitive or an object. but each of them contains the exact same type of element. So it's fixed size. In what we mean by that is you need to tell Java exactly what size the array is going to be. It can't grow, it can't shrink. The memory is allocated, it's done. And they're indexed. So each of these is an element of the array. We have 10 items in this array here. The array length is 10, but in order to access, for example, the element here, which is the third element, we would use index number 2. So what we have is we've zero-based indexing to access each of our elements. And we'll show you how to access them in a second. So if I try to access an element that didn't exist, we're back to a problem with another exception. And exceptions mean it's going to crash your program. So if I try and access an element in my array, my element is length 10. If I try and access an element, an 11th element, this is automatically bounds checked. And what will happen is it'll crash your program again with an array index out of bounds exception if you try to access it and you haven't programmatically handled for it. So declaring arrays. So you can see this here is a primitive. This here is a reference type. So I can have what are called a primitive array of either primitive values or of object types. The minute that we put the 2 square brackets here after a variable type, we are indicating that we are dealing with an array. So what I have here is I have a reference. This is an object. This is a reference to where my array will be built. Once again, if I have just done this level here and I haven't done any, called any any constructors and so on, this will be just a null pointer. So this guy is a string here. We are saying build an array of string and call it arrays of strings. I haven't given it any size yet. This is only me saying I am declaring my intention to build an array. It will be of type string. I will reference it with an array of strings variable, but I haven't built it yet. I will build it further on in my code. So these are interchangeable here. I can put the square brackets after the variable type, or I can put it after the variable name, and you can see that we have done that down here. So the second line here, the first line here is only declaring my intention that I will be building an array at some stage in my code. It will be called array of integers and it will hold a whole series of ints. And this is physically building it in memory. So this is us creating the object for the array of integers, allocating 5 spaces onto it. So we'll have an array of size 5. Once again, you'll see this keyword new. As soon as we want to build an object of some sort, we will use the keyword new. You saw it when we were using our constructors. We were calling our constructors. Constructors are invoked using the keyword new. And same here, build a new array of type integer with 5 spaces. We must specify the size when we're physically building it. There are different ways to specify the size, but you must specify it. And each of these guys, the initialization for this array of integers is the default value of int. So the default value of an int is 0. Default value of double, same again, 0. So it will be defaulted, the default value of each of those elements will be a 0. So there is another approach to building an array. We can initialize it using a string of using literals. So in this case, I can do, that's my intention to build an array of integers. And what I can do then is this physically builds it, gives it its object reference in memory. And by me passing in data, 1, 2, 3, 4, 5, which are valid ints, what it's doing is it's working out itself that it's an array of 5 and it's giving it default starting values to what we're used to, what we want here. However, we cannot do it, we cannot split it in 2 different lines. See here, this is a compile error. If we try and delay the building of our array using default values, maybe we read them in from somewhere, it's not really going to work. You have to, when you're creating your array, If you want to use a string of literals, it has to be done at the same time as you building your array. So this will give you a compile time error if you defer the initialization of it and the building of it to a later date. So if you're not using an initializer like we did using a string of literals like that, an array can be initialized by storing elements at a specific index. And this is an example here. We access each element using what we call the index. So the index is always the size of the array minus 1 is the maximum index. Indexing is always 0 based as well. So if I want to access the first element in my array that holds 5 elements, I use the index 0, and then I can assign it a value. Same here. This is the second element in my array. Give it a value of 2, and so on. So I can just, that was the previous slide showed assigning values to your array. This is accessing them for printing out values. So in this case, what we're doing here is we are saying array of integers, access the element stored at location 2. So location 2 will be the third element in our array. It's offset by 1. The index is offset by 1. So access my array of integers at location 2 and print it out to the console. And we end up with the value 3 here. We also have properties. We can access, this is a property, it's not a method call, and you'll see why it's not a method call is there are no parentheses straight after it. This is the property of an array. And what it is here is that array of integers. If I want to figure out how long my array is, what's the maximum size of my array, I can just have array of integers dot length, and it will return to me an integer indicating the exact size of my array. In this case, it will return 5 to me. We typically use this when you're using your for loops and using control statements. We typically use this in control statements rather than hard coding a value in a 5. You can also have multi-dimensional arrays. We won't cover these much in the course. It's just to follow through on the arrays here. We will start moving down the collections route, which is what's coming next week as well. But you can look at these guys here if you want in your own time. Multi-dimensional arrays, you can have any number of dimensions in an array. This one has 2 rows, 5 columns. You can have n-dimensional arrays. And this is just a diagram just to show you how the arrays, how you access them. And it's, you know, kind of all that stuff there. You can have a look at it and how they're laid out in memory. And initializing an array, multi-dimensional array, there's an example of it there as well. So we can still use our array initialization using a string of literals. That's no problem. And then accessing an element, you need your 2 indices to return the value at a location in the array. You need your row and your column. So what we've looked at so far then today is we have covered the basics and arrays, and we will be moving on after this. Eamon will be back to you in a few minutes and he will start doing all the classes. And if we have time, we will do the control statements, and we'll also talk to you about your assignment. I'm sure you're all dying to know about that. So I'll be back to you in a little bit. Okay, thank you.